Today we are going to talk all about dopamine and what drives you to do the things that you do. We're going to talk about motivation and desire and craving, but also how dopamine relates to satisfaction and our feelings of well-being. And of course, any discussion about dopamine has to include a discussion about the potential for dopamine-induced addiction. Indeed, dopamine lies at the heart of addiction to all things. But today we are mainly going to focus on how what we do and how we do it and how we conceptualize those things leads to changes in this amazing molecule in our brain and bodies that we call dopamine. I'm going to teach you what dopamine is and what it is not. There are a lot of myths about the molecule dopamine. We often hear about so-called dopamine hits. Today we are going to dispel many common myths about dopamine, and we are going to talk about how dopamine actually works. We're going to discuss the biology of dopamine, the psychology. We will discuss some neural circuits, and a really exciting aspect of dopamine biology are so-called dopamine schedules. In other words, we are going to discuss how things like food, drugs, caffeine, pornography, even some plant-based compounds can change our baseline levels of dopamine, and in doing so, they change how much dopamine we are capable of experiencing from what could be very satisfying events or events that make us feel not so good because of things that we did or took prior. So I promise you it's going to be a vast discussion, but I will structure it for you, and you'll come away with a deep understanding of really what drives you. You will also come away with a lot of tools how to leverage dopamine so that you can sustain energy, drive, and motivation for the things that are important to you over long periods of time. Before we dive into the meat of today's discussion, I'd like to share with you a fascinating result that really underscores what dopamine is capable of in our brains and bodies, and underscores the fact that just through behaviors, no drugs, nothing of that sort, just through behaviors, we can achieve terrifically high increases in dopamine that are very long and sustained in ways that serve us. This is a result that was published in the European Journal of Physiology. I'll go into it in more detail later, but essentially what it involved is having human subjects get into water of different temperatures. So it was warm water, moderately cool water, and cold water. Had them stay in that water for up to an hour, and they measured, by way of blood draw, things like cortisol, norepinephrine, and dopamine. What was fascinating is that cold water exposure led to very rapid increases in norepinephrine and epinephrine, which is also just called adrenaline. It also led to increases in dopamine, and these increases in dopamine were very significant. They kicked in around 10 or 15 minutes after submersion into the cold water, and I should mention the head wasn't below water, it was just up to the neck. And the dopamine release continued to rise and rise and rise, and eventually reached 250% above baseline. Now, what was interesting is after subjects got out of this cold water, that dopamine increase was sustained. And I know nowadays many people are interested in using cold water therapy as a way to increase metabolism and fat loss, but also to improve sense of well-being, improve cognition, improve clarity of mind. There's something really special about this very alert but calm state of mind that seems to be where too people with Parkinson's and Lewy body dementia also experience drops in motivation and affect, meaning mood. They tend to get depressed and so on. When those people are properly treated, they can, not always, but they can recover some fluidity of movement, some ability to initiate movement, and almost without question, those people feel better psychologically, not just because they can move, but also because dopamine impacts mood and motivation. So what are the underlying neural circuits? For those of you that are not interested in biology and specific nomenclature, you can tune out now if you want, but it's actually pretty straightforward. You have two main neural circuits in the brain that dopamine uses in order to exert all its effects. The first one is a pathway that goes from this area in the what's called the ventral tegmentum. That's fancy, but ventral just means bottom, and tegmentum actually means floor. So it's at the bottom of the brain, and it's the ventral part of the floor, so it's really low in the back of the brain, the ventral tegmentum, and it goes from the ventral tegmentum to what's called the ventral striatum and the prefrontal cortex. Now that's a lot of language, but basically what we call this is the mesocorticolimbic pathway. This is the pathway by which dopamine influences motivation, drive, and craving. It involves structures that some of you may have heard of before, things like nucleus accumbens and the prefrontal cortex. This is the pathway that really gets disrupted in addictions, where in particular drugs that influence the release of dopamine, like cocaine and methamphetamine, we'll talk about those drugs today, they tap into this pathway. But if you are pursuing a partner, a boyfriend or girlfriend, if you're pursuing a degree in school, if you're pursuing a finish line in a race, you are tapping into this so-called mesocorticolimbic pathway. This is the classic reward pathway in all mammals. The other pathway emerges from an area in the brain called the substantia nigra, so called because the cells in that area are dark, and the substantia nigra connects to an area of the brain called the dorsal striatum. This is, not surprisingly, called the nigrostriatal pathway. For those of you who have never done any neuroanatomy, I'm going to teach you a little trick right now. Everything in neuroanatomy, the first part of a word tells you where the neurons are. And then the second part tells you where they are connecting to. So when I say nigrostriatal pathway, it means that the neurons are in substantia nigra and they connect to the striatum, nigrostriatal pathway. So while it's a lot of language, there is some logic there. Okay, so we got these two pathways, one mainly for movement, right? This is the substantia nigra to dorsal striatum. And we've got this other pathway, the so-called mesocorticolimbic pathway, that's for reward, reinforcement, and motivation. I want you to remember that there are two pathways. If you don't remember the two pathways in detail, that's fine. But please remember that there are two pathways, because that turns out to be important later. Now, the other thing to understand about dopamine is that the way that dopamine is released in the brain and body can differ, meaning it can be very local or it can be more broad. Now, most of you have probably heard of synapses. Synapses are the little spaces between neurons. And basically neurons, nerve cells, communicate with one another by making each other electrically active or by making each other less electrically active. So here's how this works. You can imagine one nerve cell and another nerve cell with a little gap between them, a little synapse. And the way that one nerve cell causes the next nerve cell to fire, what we call fire really means to become electrically active, is that it vomits out these little packets, what we call vesicles. They're little bubbles filled with a chemical. When that chemical gene expression can actually change the way that cells behave. One thing that's not often discussed about dopamine, but is extremely important to know, is that dopamine doesn't work on its own. Neurons that release dopamine co-release glutamate. Glutamate is a neurotransmitter, and it's a neurotransmitter that is excitatory, meaning it stimulates neurons to be electrically active. So now, even if you don't know any cell biology, you should start to gain a picture that dopamine is responsible for movement, motivation, and drive. It does that through two pathways, but also the dopamine stimulates action in general because it releases this excitatory neurotransmitter. It tends to make certain neurons that are nearby or even that are far away because of volumetric release, it tends to make those more active. So dopamine is really stimulating. And indeed, we say that dopaminergic transmission, or dopamine, tends to stimulate sympathetic arousal. Sympathetic doesn't have anything to do with sympathy. It just simply means that it tends to increase our levels of alertness. It tends to bring an animal or a human into a state of more alertness, readiness, and desire to pursue things outside the confines of its skin. So if I were to just put a really simple message around dopamine, it would be there's a molecule in your brain and body that when released tends to make you look outside yourself, pursue things outside yourself, and to crave things outside yourself. The pleasure that arrives from achieving things also involves dopamine, but is mainly the consequence of other molecules. But if ever you felt lethargic and just lazy and you had no motivation or drive, that's a low dopamine state. If ever you felt really excited, motivated, even if you were a little scared to do something, maybe you did your first skydive, or you're about to do your first skydive, or you're about to do some public speaking and you really don't want to screw it up, you are in a high dopamine state. Dopamine is a universal currency in all mammals, but especially in humans. for moving us toward goals, and how much dopamine is in our system at any one time compared to how much dopamine was in our system a few minutes ago, and how much we remember enjoying a particular experience of the past. That dictates your so-called quality of life and your desire to pursue things. This is really important. Dopamine is a currency, and it's the way that you track pleasure. It's the way that you track success. It's the way that you track whether or not you are doing well or doing poorly. And that is subjective. But if your dopamine is too low, you will not feel motivated. If your dopamine is really high, you will feel motivated. And if your dopamine is somewhere in the middle, how you feel depends on whether or not you had higher dopamine a few minutes ago or lower dopamine. This is important. Your experience of life and your level of motivation and drive depends on how much dopamine you have relative to your recent experience. This is, again, something that's just not accounted for in the simple language of dopamine hits. Okay? A simple way to envision dopamine hits is every time you do something you like, you eat a piece of chocolate, dopamine hit. You look at your Instagram, dopamine hit. You see someone you like, dopamine hit. All these things described as dopamine hits neglect the fact that if you scroll social media and you see something you really like, dopamine hit. Sure, there's an increase in dopamine. But then you get to something else and you go, not that interesting. However, had you arrived at that second thing first, you might think that it was really interesting. If you had arrived to that second Instagram post 3 days, you have to give me something to get my dopamine levels back up again. And they did. They gave me an injection of L-Dopa into the bag, went straight into my bloodstream, and within minutes, I felt fine again. It was incredible, and it really opened up my mind and my experience to what it is to have absolutely plummeted levels of dopamine. There's nothing more miserable than that, I'll tell you. And these poor souls who had this MPTP experience, unfortunately, they couldn't recover those cells. People who have severe Parkinson's are struggling with this as well, because in Parkinson's and in Lewy body dementia, the dopaminergic neurons often die. It's not just a problem with those neurons releasing enough dopamine. Later, we're going to talk about some approaches to maintaining dopaminergic neuron health and things that we can all do for that. But I will tell you, these dopamine neurons that we all have are very precious for movement and mood and motivation. Having experienced what it is to have very, very low levels of dopamine, or to, in this case, to have my dopamine receptors blocked from Thorazine, was eye-opening, to say the least, and has given me tremendous sensitivity to the fact that dopamine is perhaps one of the most powerful molecules that any of us has inside of us, and the one that we ought to all think very carefully about how we leverage. Because while most experiences and most things that we do and take and eat and etc. won't create enormous highs and enormous lows in dopamine, even subtle fluctuations in dopamine really shape our perception of life and what we're capable of and how we feel. And so we want to guard those and we want to understand them. So let's lean into that understanding about dopamine, and then let's talk about some tools that we can all use to leverage dopamine in order to keep that baseline in the appropriate healthy place and still be able to access those peaks in dopamine, because those, after all, are some of what makes life rich and worth living. So let's talk about the baseline of dopamine that we all have and the peaks in dopamine that we all can achieve through different activities and things that we ingest. All of us have different baseline levels of dopamine. Some of this is sure to be genetic. Some people just simply ride at a level a little bit higher, a little bit more excited, they're a little bit more motivated. Or maybe they're a lot more excited or a lot more motivated. Some people are a little mellower. Some people are a little less excitable. And some of that has to do with the fact that dopamine doesn't act alone. Dopamine has close cousins or friends in the nervous system. And I'll just name off a few of those close cousins and friends. Epinephrine, also called adrenaline, is the main chemical driver of energy. We can't do anything at all, unless we have some level of epinephrine in our brain and body. It's released from the adrenal glands, which ride atop our kidneys. It's released from an area of the brainstem called locus coeruleus. And its release tends to wake up neural circuits in the brain and wake up various aspects of our body's physiology and give us a readiness. So it should come as no surprise that dopamine and epinephrine, aka adrenaline, hang out together. In fact, epinephrine and adrenaline are actually manufactured from dopamine. There's a biochemical pathway involving dopamine